Welcome to Bite Me. We're going to be diving into the second part for chapter 3, and we're going to be talking about functions. So let's dive into that. Okay. Functions. Functions are prevalent in Rust code. You've already seen one of the most important functions in the language, which is main. The main function, which is the entry point of many programs. You've also seen function keyword, which allows you to declare new functions. Rust code uses snake case. If you don't know what snake case, camel case, Pascal case is, essentially it's just the way that you declare, say, a variable or a function. So this is snake case. All of it is lowercase, and anything that has a space, technically, is going to have an underscore instead of like a space. You know what I mean? So it's the easiest way. You can also look up what camel case is. It's the first letter of the first word is going to be lowercase, and then all the letters after that are going to start with an uppercase letter. Easy enough. Okay. A snake case is a conventional style for function and variable names in which all the letters are lowercase and underscores separate the words. Here's a program that contains an example of a function definition, which is function main. We're we're using a printline macro to printline hello world to the terminal. And we're also putting in this another function into our main function. So they can also printline macro, another function. Okay, so the name of the function is another function. We're putting that into the main function so it can execute. And within that function, it's going to print another function, the word. We define a function in Rust by entering the following fn, followed by a function name and a set of parentheses. The curly brackets tell the compiler where the function body begins and ends. We can call a function we've defined by entering its name followed by a set of parentheses. Because another function is defined in the program, it can be called from inside the main function, right? Because our main function is our entry point. All the other functions are kind of helper functions. They're not doing anything yet until we put them in main. Note that we define another function after the main function in the source code. We've also defined it before as well. Rust doesn't care where you define your functions, only that you define it somewhere in the scope that can be seen by the caller. So usually in the same file, you can define multiple functions after and still utilize them in the main function. Let's start a new binary project called functions to explore functions further. Place another function example in source/main.irs and run it. You should see the following output. So now we did a cargo run. We've learned this in the previous section. And now you can see hello world and another function have been print line to the terminal. Remember, another function, print line that, because it's in main, so it's executing what it said. These lines execute in the order in which they appear in the main function. First, the hello world message prints, and then another function is called, and the message is printed. I'm pretty sure we're going to be talking about order of operations in this video, and you're going to see how the way that you put your code, or let's say, how do I put this in correct terms? How do you order your code? It has an impact on how it is delivered or how the output is. Okay, so we're going to be talking about that a little bit later, but for now, you could see in this function, even though another function is after the main function, because we put it after hello world within the main function, that printline macro, it's going to execute hello world and then another function. I hope that makes sense. Parameters. We can define functions to have parameters, which are special variables that are part of the function signature. When a function has parameters, you can provide it with concrete values for those parameters. Technically, the concrete values are called arguments, but in casual conversations, people tend to use the parameter and argument interchangeably for either the variables in the function's definition or the concrete values passed in which you call a function. Okay? I think of parameters like a coin slot. You like input it into your function, and it's going to have a specific output later on. So let me keep on reading and maybe it'll make a little bit more sense. Okay, in this version of another function, we add a parameter, function main, another function, and then we have a parameter within it, which is 5. Within our another function, we have a parameter x, and this is going to equal this is going to have a integer, which is 32 bits. Then we're going to print line the value of x is x. So we kind of don't know what x is yet, okay? So don't even look at this main function. Look at this another function first, okay? This is our helper function. This function, we're inputting our coin, which is x, and we want x to be an I32, an integer. We don't know which integer yet. We're print lining this text, the value of x is, and then we're inputting that parameter, this parameter that we created over here within our little placeholder. Okay? Our program kind of doesn't know what x is yet until we put it in the main function. So here we are actually calling this another function here. We have put a little number in there. Okay? This is this. They are the same. This is now the coin that we had put in there. We put 5 cents in, let's say. We were supposed to put a coin in, and we put 5 cents, and that's that's our output. Okay, that's what x is. I hope that makes a little bit more sense. Parameters are a little bit tricky to understand, and maybe we might go a little bit more in depth in it later on when we get further in the book. But for now, simple enough. I think of it as a coin. So we're going to try running this program. You should get the following output. Here, let me pull this back up. You do a cargo run. The value of x is 5. You see? X, this is now this, because we inputted that 5 within the function. That parameter is now, okay, let me just stop over explaining. Sometimes I get to that point. Okay, so the declaration of another function has a parameter named x. The type of x is specified as an I32. Then we pass 5 into another function. The print line macro puts 5 where the pair of curly brackets were containing x in the format string. Essentially what I said. In function signatures, you must declare the type of each parameter. This is deliberate decision in Rust design, requiring type annotations in function definitions means that the compiler almost never needs to use them elsewhere in the code to figure out what type you mean, okay? Get in the habit of typing all of your variables, get in the habit of typing all of your parameters. It's just something that the Rust language wants you to integrate. Just get used to it. Get used to it. Where'd I go? Okay, deliberate decision, Rust annotations. Okay, this is a deliberate decision in Rust design requiring type annotations and function definitions means that the compiler almost never needs you to use them elsewhere in the code to figure out what they mean. The compiler also is able to give you a more helpful error message if they know what type of function, the types of function, the function expects, which they were already expecting an integer and received 1. This example creates a function named print underscore labels underscore measurement with 2 parameters. Okay, before we get into this, let's read this real quick. So we have a main function over here. Let's not look at the main function yet. I know they always put it first. Don't like that. It's a bit confusing. Let's look at these helper function first. So we have this function. We named it print underscore label measurement. We have 2 parameters that were put in here. We have one for value, one for unit label. One is a I32, which is an integer, and another one is a character. And remember, characters are only used with single quotations. Okay? We're doing a print line macro. The measurement is blank, our placeholder value, and then our unit label. We don't know what our value is yet. We don't know what our unit label is. They're just placeholders, okay? Nothing has been executed yet. Now let's take a look at function main. Okay, this is where all the execution happens. We are calling this function print labeled measurement, and we're inputting these 2 parameters. So we have a parameter for, and make sure you do this in order. Don't be messing up the order, okay? That's how you get compiler errors, okay? We have our value, which is now 5. That was our I32, remember? This is our coin. And then we have our unit label, which is our character, and that's going to be H. So we're going to have this line will be executed within our main function into our terminal. And let's read on. I'll keep this so we can see it later. This example creates a function named print labeled measurement with 2 parameters. The first parameter is named value and is an I32. The second parameter is unit label and the type is char or character. The function then prints text containing both the value and the unit label. Alright, and then let's try running this code. Replace the program currently in your functions project with source main file, and you could do this within your project just to get like the hands-on experience. I don't feel like it's necessary because they're showing you all of the compiled like functions. So I don't feel like it's necessary. I think you should definitely do it. Go to your function, go to your projects folder, and put that into main. Create some helper functions that don't do anything until you execute it in main. That will help you astronomically. It is good to practice. Practice, practice, practice makes perfect, okay? But today I'm just reading. Okay, then we do a cargo run and we can see that the measurement is 5H. Now, okay, you would think that there might be a space, but because we never inputted a space or maybe a quotation with a space within it, there's not going to be a space between it, okay? That's something that you would have to input yourself. You would have to add that. Okay. Because we call the function 5 as a value for value and H as a value for unit label, the program output contains those values. Right. Statements and expressions. Function bodies are made up of a series of statements optionally ending in the expression. So far, the functions we've covered haven't included any ending expression, but you have seen an expression as part of a statement. Because Rust is an expression-based language, it is an important distinction to understand. Other languages don't have the same distinctions, so let's look at what statements and expressions are and how their differences affect the bodies of functions. Statements. Statements are instructions that perform some action and don't return a value. And then expressions evaluate a resultant value. Let's look at some examples. We've already used statements and expressions, creating a variable and assigning a value to it with a let keyword is a statement. Like let y equal 6 is a statement with a very good distinction between a statement and an expression will be this semicolon right here. The semicolon is a statement. It will always be a statement if it has a semicolon at the end. If it does not, it is an expression. And that's a really good distinction between the two. Okay, so function main, we have let y equal 6. That's our statement. So our function definitions are also statements. The entire preceding example is a statement in itself. It's not returning anything. We're just stating that y is bound to 6. As we'll see shortly, calling a function is not a statement though. Statements do not return values. Therefore, you cannot assign a let statement to another variable as the following code tries to do. You'll get an error. Now, function main, let x equal let y equal 6. That's not correct. You cannot be doing that. When you run this program, the error you'll get looks like this. Right here, it's telling you only supported directly in conditions of if and while expressions. Unnecessary parentheses around assigned values. So you would have to move these parentheses. Let x equal let y equal 6. If anything, you could do let x equal, well, okay. Don't listen to me. I'm like thinking out loud, but don't listen to me. Anyway. All right, the let y equals 6 statement does not return a value, so there isn't any x to bind it to. Right. This is different from what happens when in other languages such as C or Ruby, where the assignment returns the value of the assignment. In those languages, you can write x equals y equals 6, and have both y and x have the same value of 6. That is not the same case in Rust, okay? Expressions evaluate to a value that make up most of the rest of the code that you'll write in Rust. Consider a math operation, such as 5 plus 6, which is an expression that evaluates the value 11. Expressions can be part of statements. In listing 3-1, the 6 in the statement, let y equal 6, is an expression that evaluates to the value 6. Calling a function is an expression. Calling a macro is an expression. A new scope block created with curly brackets is an expression, for example. So, you could see even here when I was talking about expressions, like the distinction between expressions would be that semicolon. You can see here in function main, you can see here in function main, you do a let y equal, let x equal 3, and then x plus 1. Okay, this portion is the expression. Okay, this let statement together is a statement, but this portion right here is the expression. So is the block that, whoa, where is this? Oh, okay. This expression is a block that in this case evaluates to 4. The value gets bound to y as part of the let statement. Note that x plus 1 line without a semicolon at the end, which is unlike most of the lines you've seen so far. Expressions do not include ending semicolons. I can't express this enough. If you add a semicolon at the end of the expression, you turn it into a statement, and that will not return a value. keep in mind as you explore function return values and expressions next. So, okay. So let y is equal to this whole thing right there. So we know x is equal to 3, so x plus 1 would be 3 plus 1, and that would equal to y. This is the part that's the expression. This is a statement. All of that is a statement. Then we're just returning y right here on this println macro, and then it's going to return 4. It's just showing you the difference between the statements and the expressions. Functions with return values. Okay, functions can return values in the code that calls them. We don't name return values, but we must declare the type after an arrow. And this is going to be at the beginning of your function. In Rust, the return value of the function is synonymous with the value of the final expression in the block of the body of the function, of a function. You can return early from a function by using the return keyword and specifying a value, but most functions return the last expression implicitly. Here is an example of the function that returns a value. So here we have our function 5. Thank goodness they put this before the main function. I don't like when they put the main function before the helper function. All right, anyway. So now we have the function 5. We're returning an i32 bit, and we see this little expression here, and you can tell it's an expression because it doesn't have a semicolon. Keep up. Anyway, all right. So function main. Now where we don't have any parameters, we're just diving in, and we're going to let x equal 5. Now, right, because 5 is our function. We're calling our function 5 to bind to x. Now we're printlning the value of x is equal to, what is x now? X is now 5 because the function 5 returns the number 5 as an expression because expressions are returned, like they return, okay? If it had a statement, we would have to bind it to a variable, and it would be like this. It is a perfect example. We would have to bind it to a variable by using the let statement. Okay? And right here where this placeholder is, it's going to have the number 5. So let's see what it returns. There are no function calls, macros, or even let statements in the 5 function, just a number 5 by itself. And that's a perfectly valid function in Rust. Note that the function's return type is specified too as a return of i32, which they knew that it's going to be an integer, which we should always do, return the i32. So they knew it was going to return something. Try running this code, and this is the output. It's going to be the value of x is equal to 5. The 5 in the 5 function is the function's return value, which is why the return type is an i32. Let's examine this in more detail. There are 2 important bits. First, the line let x equal 5, the 5 function, shows that we're using a return value of the function to initialize a variable. Because that function 5 returns a 5, that line is the same as following let x equals 5, right? Second, the 5 function has no parameters and defines the type of value, but the body of the function is a lonely 5 with no semicolon because it is an expression whose value we want to return. All right, we're returning that i32, that's the value 5. All right. Sorry, I'm just getting so passionate about expressions today. I feel like it's a good thing. Be very passionate about what you want to learn and what you want to do. All right, let's keep going. Let's look at another example. So function main, and then we let x equal plus 1. Here we go. Let's talk about this one first, okay? So we have a function plus 1, okay, and it has a parameter of x, which is an I32, and it's going to return an I32, okay? So then we have x plus 1. So we don't know what x is yet. We have no idea who x is. We just know that this function is going to return some value, and it's going to be an integer, okay? Now we go over here to main. We have a function main. Let x equal plus 1. We're calling this function up here in plus 1, and we're inputting a parameter within it. So now this, remember this is our coin slot. Right here, we had no sense. It just had a coin slot. It said input something. We inputted a $5 coin or a 5-cent coin into that coin slot, and this is how we do it. Okay? So we have that statement. So we have a plus 1, now we have a 5 here, right? And now we know that x is 5. And x, which is 5 now, 5 plus 1, that's going to be 6. And then we do a print line statement over here, and the value of x is 6. Perfect. All right, running this code will print the value of x is 6. But what happens if we place a semicolon at the end of the containing x plus 1, changing it from an expression to a statement? Now, what is going to happen? We don't know. Look at this. Look at this confused ass Rust crab. Okay, look at Krabby over here. He looks so confused. He literally has a question mark coming out of him. Like, how is that even biologically possible? Yeah, so we have a main function. We have the same functions, but instead we're going to have a semicolon. So this compiling this code will produce an error as follows. We're running this code, and it says function plus 1 with the parameter of an I32 returning an I32. It says implicitly returns as the body, but no tail or return expression. So we're telling it it's supposed to return something. And then when we put that semicolon there, what did we do? We stunted it. We stopped it. We said, no, there's no actual return. So it's now panicking and saying there's supposed to be a return here because we have returned this arrow that says it's going to return, and then it doesn't. And then the main error message, mismatch types, reveals that the core issue with this code, the definition of the function plus 1 says it will return an I32, but the statement doesn't evaluate to the value, which is expressed by the parentheses, the unit type. Now, therefore, nothing is returned, which contradicts the function definition and results in an error. In the output, Rust provides a message to possibly help rectify this issue by removing the semicolon, which will fix the error. And that's how you fix it. We're going to be moving on from functions to comments. Alright, this is a really short section. Comments are very useful within Rust, within any other language, when you're working on a project with multiple different people, when you are writing notes for yourself in the future, when you're referencing back to a previous project. Your comments will be helpful or not helpful, and you really want to have helpful comments in there. So this is how to have helpful comments. All programmers, let me move in a little bit. All programmers strive to make their code easy to understand, but sometimes extra explanation is warranted. In cases, programmers leave comments in their code that the compiler will ignore, but the people reading the source code may find helpful. Alright, here's a simple comment. Hello world. it's just going to be 2 backslashes. Is that a backslash or a forward slash? I think that's a forward slash. 2 forward slashes. And you can write whatever you want, and it will not be compiled. You could put spaces, you could put whatever. In Rust, the idiomatic comment style starts with 2 slashes, and the comment continues until the end of the line. So it is forward slash, I think. For comments that extend beyond a single line, you'll need to include 2 forward slashes on each line like this. Comments can also be placed at the end of the lines containing code, like this. So this is my code. Just put it on the end of the line. When you'll more than often see this used in the format, the comment on the line, on a separate line above the code is annotating, like that. Also, another kind of comment, documentation comments. We'll discuss this in Publishing a Crate or Crates.io in Chapter 14. Okay, comments is like very simple. I would say make it descriptive, make it brief and concise, okay? You don't have to go all out with your comments. Just something that you need to remember. I've written so many comments within my projects, and they have helped me in later use. Okay? And you may be helping somebody you don't even know yet. Like if you had a project and you have multiple people on it and you write a comment and this person is reading your code, it is so useful, so helpful. Use comments wisely, but use them enough, okay? Control flow. Well, let's see. What are we talking about? Yeah, control flow. The ability to run some code depends on whether the condition is true. These are kind of my favorite. I love if expressions. I love if else expressions. Okay, so the condition is true and the ability to run some code repeatedly while the condition is true are basic building blocks in programming languages. The most common constructs that let you control the flow of execution of Rust are if expressions and loops. Now, an if expression allows you to branch your code depending on conditions. You provide a condition and then state, if this condition is met, run this block of code. If this condition is not met, don't run this block of code. Okay? Easy enough, right? Create a new project called branches in your projects directory to explore the if expression in the source/main.rs file. Input the following. Okay, so this is really good. I would say do open up your projects. I'm not going to do it because I'm just going to be reading today. But please follow along, and if you open up your projects folder, create another area called branches as it says, or whatever you want to call it. Change directory into that folder. We've done this in the last video. I've showed it multiple times. And I say if else expressions are really, really, really key to learning how to organize your code correctly. So it's very useful. Anyway, so within your source.main file, we're going to do a function main, and we're doing our first if expression, okay? So we're letting this number equal 3. We're binding this word number to this integer 3. We're creating an if expression by starting off with if. If this variable, and this is less than 5, this integer 5, then print this condition. So if that variable is less than the number 5 or integer 5, you're going to print this condition. This else, which you're going to put on every single if expression, else print this condition. So if anything is, let's say if anything is 1, 2, 3, 4, okay, it's going to print condition was true. If anything else is bound to this number 3, it will print this else statement, which is condition is false. Anything else, it doesn't matter. It's well, let's just read. I'm over here thinking too hard. All if expressions start with the keyword if, followed by a condition. In this case, the condition checks whether or not the variable number is a value less than 5. We place a block of code in, to execute if the condition is true. Immediately after the condition, inside curly brackets, blocks of code associated with the conditions in if expressions are sometimes called arms. Just like the arms in the match expressions that we discussed in comparing the guess to the secret number section of chapter 2, optionally we can include an else expression. I would not say optionally. I think that's a bad choice of words. You should always use an else expression within your if expressions. It's just good, I would say good manners. Yeah. Okay, so we include an else expression, which we choose to do here to give the program an alternative block of code to execute should the condition evaluate to false. Okay. Yeah, I just wouldn't put optionally. I would say always add it. If the conditions don't match the first block and you need to put it. It's not an option. I don't know how to explain it in any other way. I feel like I have a good explanation in my head and I can't verbalize it right now, but just believe me when I say you need it. Okay? If you don't provide an else expression and the condition is false, the program will just skip the if block and move on to the next bit of code. And what if there's no other bit of code after that? And it crashes, and your code crashes because you didn't put all of the conditions. So let's try changing the value of the number to a value that makes the condition false to see what happens. Let number equal 7. Run the program again and look at the output. It says condition is false or was false. Now, it's also worth noting that the condition in this code must be a bool. And we know what bools are. If the condition is not a bool, we'll get an error. So remember within our last chapter, we talked about data types. Bool is one of them, or Boolean is one of them, and that is going to be true or false. That's it. You can also type the parameters, not the parameter, the type of variable you're trying to return, which is a bool or true, false. It's good to type your stuff. Okay, we have function main. Let number equal 3. If number, and then print line, number was 3. So this is shorthand. This is a way, oh, here we go. Yeah. The if condition evaluates that the value of 3 this time, and Rust throws an error. Oh, what the heck? Let's keep reading. The error indicates that Rust expected a bool, but got an integer. Unlike languages such as Ruby and JavaScript, Rust will not automatically try to convert a non-Boolean type to a bool. To a Boolean, my bad. You must be explicit and always provide if with a Boolean as its condition. If we want an if code block to run only when the number is not equal to 0, for example, we can change the if block to the following. Oh my gosh. I didn't sleep too much last night. So I'm a little bit sleepy. But we must go on. Okay, I think this is the last, yeah, this is the last part of this chapter, which is our if blocks. All right. Running this code will print number with something other than 0. Okay, essentially what I was trying to say is that this integer, it's not an if block. It's just kind of stating that number is 3. If number 3 doesn't make any sense. I kind of use it as an if statement. So if something were to happen, then this event will happen. So it's like like a consequence of your statement. So if this possibility were to happen, if this was less than or equal to this number, then this will execute. And if that doesn't happen, then this will execute. And then we're going to be talking about else if, which are other if statements that will go in order, okay? So handling multiple conditions with else if. You can use multiple conditions by combining if and else and an else if expression. For example, here we got main. We have our number bound to this integer 6. If number, which is our variable, mod 4, so this modulus is a remainder. So remainder 4, which is 2, is equal to 0, then print this. Number is divisible by 4. So it's asking if this number, let number, is divisible evenly by 4. It will equal 0, right? There will be no remainder. This is a modulus which only has remainders. So if now we know what the remainder will be. It will be not equal to 0. So this would be wrong. This condition is the condition that it wants. But if that's not correct, then else if number mod 3 equals 0. So it's saying if 6 is evenly divisible by 3, it will equal 0. And if that is correct, then the number is divisible by 3. And this is where it gets a little bit complicated, and I would say the order of operations will be the largest to the smallest in this sense. Because if this is correct, then it will stop and exit the program. Okay? And you're going to see this in a little bit. Because you know that this number, else if number modulus 2, is divisible correctly by 3 and it will equal 0, it would print this as well. This number, this print line. But you're going to see in this one, let's see, this program has 4 possible paths it can take. After running it, you should see the following output, which is this number is divisible by 3. And why did it not say this number is divisible by 3 and this number is divisible by 2? It is the way that we ordered it. And that is why it never got to it. It exited the program before it got to the next else if block. So that condition was already met. The condition was met and it exited the program. This program executes, it checks if each if expression in turn and executes the first body, which the if evaluates is true. So if the first one is true, the next one will never be seen. Note that even though 6 is divisible by 2, we don't see an output number is divisible by 2, nor do we see number is divisible by 4, 3, or 2 text from the else block. That's because Rust only executes the block that is first true condition, and once it finds it, it doesn't even check the rest. All right. Sorry, I was just checking something else. All right. Using too many else-if expressions can clutter your code. So if you have more than one, you might want to refactor your code. Chapter 6 describes a powerful Rust branching construct called match for these cases. And match is kind of like an if expression, but you have to satisfy all of the possibilities. And the else expression in this one, you see this one has an if and also an else, which is satisfying all possible possibilities. If they do not, if all these conditions are not met, this will be the last condition met. Okay? That's why I'm saying that you need an else expression. It's not optional. Okay, using an if in an let statement. Because if is an expression, we can use it on the right side of the let statement to assign the outcome to a variable, as listing in 3-2. Our function main, we have a let condition, which is our variable, bound to this boolean, which is true. Let number, which is our variable, equal an if expression, which is in shorthand. Okay, so if this condition is true, else, which is 5, else 6. Okay, so if this condition is not met, is not true, then this condition will be met. Then we're going to print line the number is number. And obviously you can see the compiled data, but without looking, you would know that this condition is true because what? The condition variable is bound to true, which is a boolean. And the if-else expressions use true or false as a condition met or not met. And that's something that just, you need to stick in your head. The if-else expression is true or false. If it is not true, it will always be false. Okay. The number variable will be bound to the value based on the outcome of the if expression. Run this code to see what happens. And we can see that the value of the number is 5, which is the true expression. Remember that the blocks of code evaluate the last expression in them, and the numbers by themselves are also expressions. In this case, the value of the whole if expression depends on which block of the code executes. Okay, sorry. Sometimes I don't read correctly. I think I need a water break right now. Get a little water. Get a little hydrated, okay? All right. Whew. A lot of reading already. Okay, I think we're back in session. Okay, remember that the blocks of code evaluate the last expression in them, and the numbers by themselves are also expressions. In this case, the value of the whole if expression depends on which block of code executes. Now, this means that the values that have potential to be results from each arm of the if must be the same type. I don't like how that was worded. This means that the values that have the potential to be results from each arm of if must be the same type. In listing 3-2, the results of both if arm and else arm are an I32 integer, and those types are if the types are mismatched, as the following example, we'll get an error. Okay? Now you can see this one is 6 too. Okay? But we changed it to be a string, so it's not the same. When we try to compile this code, we'll get an error, And the if-else arms have value types that are incompatible. And Rust indicates exactly where to find a problem in the program. Okay? So it says expected because of this. So we have this little statement right here where we bound a number to this if-else statement, if-else expression, and it's expecting an integer, but it found a string, and it doesn't like it. It doesn't like that. It says it needs to be an integer because this is what we originally expected. Now, the expression in the if block evaluates to an integer, and the expression in the else block evaluates to a string. This won't work because variables that have a single type, and Rust needs to know definitively at compile time what type the number variable is. Okay? Which our number variable is an integer. So, exactly. Well, the number variable, wait, hold on. No, condition variable was true. Okay, the number variable was the if-else statement. My bad. Short-term memory loss. Okay, we're back at it. Knowing the number type lets the compiler verify the type is valid everywhere when we use number. Rust won't be able to do that if the type of number was only determined at runtime. The compiler would be more complex and would make fewer guarantees about the code if it had to keep track of multiple theoretical or hypothetical types for any variable. We want our compiler to know what we're going to introduce to it. We don't want extra thinking at runtime, okay? When we compile our code, our compiler should be able to assess, okay, I'm able to compile everything and everything is explicitly said within your code. It's just easier for her. You don't want to hurt your compiler. She's doing you justice, okay? She's helping you. She's giving you she's telling you about all the bugs in your code. She's such a helpful girl, okay? Just give her a break. Repetition with loops. It's often useful to execute a block of code more than once. For this task, Rust provides several loops which will run through in the code because we did go through loops last time inside the loop body to end and then start immediately back at the beginning. To experiment with loops, let's make a new project called Loops. Thank goodness. Okay, so loops are very, very essential. And we did go through one of the loops that is in Rust called loop in the last one. So there's actually 3 types of loops. There's a loop, while loop, a for loop, and a loop loop. So we went through the loop loop, and we're going to go through the rest. I highly, I would say open up your projects folder, go through these, understand for loops, understand while loops, understand how they work and operate. And I think I do want to have like another series where I'm going through all these more basic, loops and for loops, and we're talking about data types and how it works, and we might do like mini projects. That would be fun. I think that would be a good time, and I might have to develop that myself. I was going to go through somebody else's, but I think it would be easier for me to develop my own projects, and then I might put them on GitHub. So stay tuned for that. These are just some ideas I'm throwing out there. If anyone would like to do them, I might do my whole series on that too. Whoa! What happened to my camera? This camera has been giving me, this is my phone, but This has been giving me issues all day, so let's just finish this up because I don't know what's going on with it. Alright, so, alright, a loop. When we run this program, we'll see again, which is right here, printed over and over continuously until we stop the program manually because we're just using loop. Most terminals support the keyword shortcut Control-C or Command-C if you have a Mac to interrupt the program that is stuck in a continual loop. Give it a try. Are you trying it? Alright, you see it's stuck, but you see right here, that symbol represents where we're pressed that Control-C or Command-C. You may or may not see that word again printed after that symbol, the Command-C symbol, depending on where the code was in the loop when you receive the interrupt signal. Fortunately, Rust also provides a way to break out of the loop by using code. We can place the break keyword within the loop to tell the program when to stop executing the loop. Recall that we did this in the guessing game in the quitting after correct guess section of chapter 2 to exit the program, when the user won the game by guessing the correct number. We also use continue in the guessing game, which in a loop tells the program to skip over any remaining code in this iteration of the loop and then go to the next iteration. Returning values from loops. One of the uses of a loop is to retry an operation you know might fail, such as checking whether a thread has completed its job. You might also need to pass the result of the operation out of the loop to the rest of your code. To do this, you can add the value you want to return after the break expression. You can use to stop the loop. That value will be returned out of the loop, so you can use it as shown here. Okay. So you have your main function. You have a let statement, mutable let statement because we have this mute here, but we have a counter. Okay. Counter is at 0. Then we're binding this result to a loop, which this loop is going to start, and it's going to start by using that counter to, this is a shorthand, to add 1 every single time it goes through that loop. Okay? Now, we have an if statement where this counter is equal to 10. If it's equal to 10, then we break the counter times 2. Okay? So it's going to break out of this once it hits this 10. Okay? So break counter times 2. I don't know what that times 2 means, but we're just going to keep reading. Before the loop, we'll declare a variable named counter and initialize it to 0. Then we declare a variable named result to hold the value returned from the loop. On every iteration of the loop, we add 1 to the counter variable and then check whether the counter is equal to 10. Yes. So every single time it goes over, the counter goes to 1. It keeps going, 2, keeps going, 3, until it's getting to 10. Once it gets to the 10, it's going to go through this block of code. This block of code. All right. When we use the break keyword with the value counter times 2, I don't know what the times 2 really means. I thought they were going to explain it. Okay. Oh, okay. I guess they wanted this counter to equal 10, and then they times it by 2, and then they have the print line as the result of 10 times 2, which is 20. I don't understand why they did that. Yeah, I don't understand why they did that. That doesn't make any sense to me. But whatever, to each their own. After the loop, we use a semicolon at the end of the statement that assigns the value to result. Finally, we print the result, which in this case is 20. Okay, you can also use a return from inside a loop. While break only exits the current loop, return always exits the current function. Okay. Disambiguating with loop labels. Okay, if you have loops within loops, break and continue apply in the innermost loop at that point. You can optionally specify a loop label on the loop that you can use when you break, or continue to specify that those keywords apply to the label loop instead of the innermost loop. Loop labels must begin with a single quote. Here's an example of with two nested loops. Okay. Nested loops are my least favorite. I don't like reading them. They're too messy. I say keep your loops to maybe minimum 2-3 nested loops max. Okay. We do not need just make another function at that point. What are you doing all that for? Anyway, so we have a main function. We're having this mutable variable count bound to 0. Then we have our loop, our nested loop, and that is going to be named counting up. You see how nested loop is with the quotation. Then we have loop, print line count equals count. So this right here is printing out the counter. So you can see it in the terminal every time it counts. Let mute remaining equal 10. So this variable is now going to be bound to this number 10, and it's going to be mutable. Now we have this other loop. So we're going to do a print line remaining equals remaining. Now if remaining, so 10 is remaining, and every single time that it's going to go through that loop, I'm pretty sure we're going to be subtracting from it because we're looking for the remaining or the remainder. Okay? If remaining, which is 10, if remaining is equal to 9, then break. Okay? Now we have another if statement in there. I know this is getting really confusing. If count is equal to 2, break. Counting up. Okay? Now remaining is going to, what we're doing here is we're taking this 10, and every single time it's going through this loop, it's going to be subtracting 1 from it. So every time it starts at 10, and then we go through the loop, and then it's going to go to 9, and then it's going to go to 8, and then it's going to go to 7, right? For counting, which counting is at 0, you see here, it's going to be doing the opposite. When count gets to 2, then it's going to break. But at this point, it's going to be at 0, and then it's going to go through the loop, and then it's going to go to 1, and then it's going to go to 2. Okay? So print line end count, and then it's going to show you when it ended. Okay? I hope that makes sense. I hope that makes sense. This is very confusing. I don't like how they formatted it right here, but counting is going up. Okay, every time it goes through the loop, and then the remaining is going down. And we want to break at the number 9, and we want count to break at the number 2. I hope that you're following. Okay, so the outer loop, let me leave this up here so you can see it. The outer loop of the label is counting up, and it will count up from 0 to 2. The inner loop without a label counts down from 10 to 9. Now the first break that doesn't specify a label will exit the inner loop only, and the break counting up statement will exit the outer loop. This code prints count 0, remaining 10, remaining 9, count 1, remaining 10, remaining 9, count 2, remaining 10, remaining 2. Okay, end count. They could have made an easier way of describing that, but just have me describe the most complicated code. Okay, streamlining conditional loops with while. A program will often need to evaluate a condition within a loop. While the condition is true, the loop runs. When the condition ceases to be true, the program calls break, stopping the loop. If it's possible to implement behavior like this when using a combination of loop, if, else, and break. You could try that now in a program if you'd like. However, this pattern is so common that Rust has built-in language construct for it, called a while loop. Okay? So, while loop. Oh, I thought I was going to talk about while loop. Okay. In listing 3-3, we use while to loop the program 3 times, counting down each time, and then after the loop, to print a message and exit. I think a while loop is like while something is happening, this program is running. It's usually used within games, because a lot of things are happening at once in a game. You still want your program to run and exit when you you have a couple of lives, you exit at the end of that last life. You know what I mean? It's like Pac-Man. Okay, so function main, let mutable variable number equal 3, which is our integer, while number or variable is not equal to 0, print line the number, okay, which is 3 at this point right now, and then number, this is going to be number, it subtracts 1 every single time you go through the loop, okay? So this construct eliminates a lot of nesting that would be necessary if you use loop, if, else, break, and it's clearer and cleaner, essentially. While a condition evaluates to true, the code runs, otherwise it exits the loop. Sorry, I didn't notice I had my fan on. I'm so sorry about that. I just noticed it was really hot in here. It was really, really, really hot in here. Okay. So essentially what we're doing is the same thing as last time. We're going through the loop each time and we're waiting until we get to 0. We're not 0, not equal to 0. Okay, so we want to get to like 1, and then I guess it's going to print line lift off. Okay. We're almost at the end. Looping through a collection with for. So you can use the while construct to loop over the elements of the collection, such as an array. For example, the loop in listing 3-4 prints an array, prints each element in the array A. Okay, this is our array. We talked about arrays last time, or last chapter, and remember that arrays are supposed to be the same values, so we have all numbers here, is the same set number of values. So it's 10 to 50, and then we have a mutable variable named index equals or bound to 0, and then while this index is less than 5, which it currently is, print line the value, which is index. We're indexing this array, okay? So this is a placeholder. Remember how we index with arrays? We put brackets on each side of it. So this would be a bracket 0, which we would have the first one. Remember, we're starting at 0 always. We start counting at 0. So this would be 0, and then it's going to go through the loop again, and then it would go to 20 because we're going up because we're adding to our index, which is 0 right now, but we're adding 1 every time it goes through the loop. I hope this is making sense. I know it's a little bit difficult to comprehend, especially if you're a very new beginner to learning how to code. Sometimes it's a lot of math, and I'm not very good at math, okay? But after a while, when you see the same repeating patterns, you get used to it, and you'll understand later on. Just keep trying, keep going. The only way is through. Okay, here the code counts up through the elements in the array. It starts at index 0 and then loops until it reaches the final index in the array. So, right, we're indexing it. We are print lining that index over here. So it's going to be 10, 20, 30, 40, 50 that the value is, okay? Running this code will print every element in the array until it finishes, which we want it to be less than 5, and we only have an index till 4. So we'll stop. Okay, all 5 array values appear in the terminal as expected. Even through index, we reach a value of 5 at some point. The loop stopped executing before trying to fetch that 6 value from the array. However, this approach is error prone. We could cause the program to panic if the index value or test condition is incorrect. For example, if you change the definition of A array to have 4 elements, but forgot to update the condition of while index is less than 4. Now, the code would panic. It's also slow because the compiler adds runtime code to perform the conditional check of whether the index is within the bounds of the array or every iteration through the loop. As a more concise alternative, you can use a for loop and execute some code for each item in the collection. So for loop kind of looks like this. For an element in this collection. It's kind of how for this one specific thing in this collection, that's how I see for loops. It's hard to explain. You just gotta keep doing them. You just gotta keep doing them, and you'll understand like the syntactual similarities every time you do a for loop. Okay. Neck. Okay. All right, so we have our main function. We let A, which is an array, equal to this whole array right here, 10 through 50, our same array as last time. We have a for loop, which is going to be for element. So we're putting a variable as a piece of an array, the piece of an array, okay? This is the best way I can explain it. I hope it makes sense. Okay, so for this piece of this array, in this array, okay, or A, in this collection, we're going to print line the value of the element. So it seems a little weird, but we're going to keep reading on and I'm going to show you, it's going to make a little bit more sense. When we run this code, you'll see the same output as listing. Here, let me see if we can run it. There we go. Okay, when we run this code, you'll see the same output as the listing 3-4. More importantly, we've now increased the safety of our code by eliminating the chance of bugs that might result from going on beyond the end of the array or not going far enough and missing some items. So essentially what we did is we were saying just print everything in this array. So print every element within this collection. Okay. Machine code generated from for loops can be more efficient as well because the index doesn't need to be compared to the length of the array in every iteration. Using the for loop, you wouldn't need to remember to change any other code if you change the number of values in the array as you would with the method used in listing 3-4. Now, the safety and conciseness of for loops make them the most commonly used loop construction in Rust and in a lot of other languages as well. Even in situations in which you would run some code a certain number of times, as in a countdown example that use a while loop in listing 3-3, most workstations would use a for loop. That way you would be able to use a range provided by the standard library, which generates all numbers in the sequence starting from 1 and ending in another number. So we're going to look at a range. Here's what a countdown would look like for a for loop, and another method that we've not talked about, which is REV, or reverse the range. So they're bringing other things in from the standard library that you can utilize, and it just makes your code a little bit more clean. So if we're using a for loop here in our main function, we have for a number in this is not a collection, but this is a range. Within this range, so this is how you specify a range. You're going to specify the first number, dot, dot, and then your last number. But if you do not put an equal sign before that last number, it will not be included into that range. So it's going to start from 3, not 4, if that makes sense. So it's going to be 1, 2, 3 in this range. But if I put an equal sign before this 4, it will include the 4 in it. So it'll be 1, 2, 3, 4. We're adding another method called rev, or reverse, and we're taking that from the standard library, and we're print lining the number, which is going to be every number that is within this range, but we're reversing it. So it's going to be 3, 2, 1, not 1, 2, 3. And we're print lining liftoff. So this code is a bit nicer. Let's just run this. Yep, and then it's 3, 2, 1, liftoff. Cute. Okay, so this is what we did today. You made it! This is a sizable chapter. You learned about variables, scalar and compound data types, functions, comments, if expressions, and loops. To practice with these concepts discussed in this chapter, try building a program to do the following. Convert temperatures between Fahrenheit and Celsius. That's a good fun one. Generate the nth Fibonacci number. I've never done that. I barely know what Fibonacci is. I'm sorry. Print the lyrics to Christmas Carol, The 12 Days of Christmas, taking advantage of the repetition of the song. That's a good one, especially if you are using your for loops, or you want to just practice on any type of loop, while loop, for loop, all the fun stuff. Alright. My voice was actually kind of gone this morning, but you know what? I persevered and read through this sizable chapter. I wanted to say a little something at the end. I forgot what I was going to say, but essentially, I want you guys to keep learning. This series it's mostly for me, but it's also really for you, and I think it's best when I'm learning with other people. We're also talking about a lot of concepts here, and so it's very fast paced and all kind of condensed because it isn't a book form. But keep learning. If it's difficult, if these chapters were a bit confusing, dive deeper. Use ChatGPT, use Google, use your resources, use documentation. That is what that is here for. Also use each other. There's Discords for new Rustaceans. I don't remember what it's called, but you can look it up. I'm probably on there. You might not know my profile name because I barely know it, but go on Discord, go on Slack pages, go on Reddit. There's so much knowledge out there, and I don't know how old you are, but as an adult, I can see a lot of people do not value knowledge as much. But it's fucking hot. You need to be sexy, you need to be hot, and it's hot to know things, okay? It's hot to have new things under your belt. So keep learning, and I'll see you for our last session tomorrow. I'm going to be streaming Tuesday through Friday every week. So you'll see a new video tomorrow or new streaming tomorrow. And then I'm trying to put out a video next week that is an edited video, not a stream. So let's see about that. Okay, I'll see you guys later. Bye.